All right, take it away.
All right, thank you very much. Great to be here. I wish I was out in Montana right now, but I'm in Baltimore on the East Coast where I retired. Lived in California for a long time and worked at the Alf Museum. So I'm going to talk about the vertebrate fossils, mainly mammals from the Tertiary basins of Southwest Montana. And when you drive around, every valley is a little different as far as the strata, and this is from the Sage Creek area. Even when I'm driving around, I'm always looking at tertiary rocks and I'm thinking, I wonder what age those are. And some of them have been dated, some are not, but really what's really important is the mammals, finding mammals. If you look on the picture, you can see a little bunch of people on the left side of that outcrop. There's a massive amount of tertiary terrestrial rock in western North America from like Canada to Texas, Kansas to California, and correlating these rocks without, way back when there wasn't radiometric dating or paleomag, was basically done by mammals. Mammals have very distinctive teeth. The teeth preserve really well. So you can tell the type of mammal from the teeth, and mammals evolve quickly. So as time goes on, there's lots of turnover. And so if you can really figure out the age of rock with, even my example is one specimen. This is a Paleocyops fontinalis. It's a brontotherium. It's like a rhino-like animal that's totally extinct now. And this animal is really well known from the Bridger Basin. And it's an upper tooth. It has four main cusps. And based on its size and its features, yeah, this is definitely Bridgerian, early 80s. And mammalian paleontologists worked in the Western US starting in the late 1800s, and they amassed these huge collections of fossils from different localities. And then they tried to, put them in the sequence. And they used stage of evolution. A lot of the really old rocks, like the Paleocene rocks, those groups of mammals are extinct. But when you get to about Oligocene, then quite a bit of those mammals still have modern representatives. So there's kind of a steady turnover of faunas. And they started to talk about faunas, just kind of, not officially, but, like the Barstow Formation, for instance. It's Miocene. They would call it, the Barstow fauna, or the Puercan fauna, or the Shadron fauna. And the Wood Committee got together in 1941. All these mammalian paleontologists had a massive amount of data, and they put together a timescale called North American land mammal ages. Because the European terms didn't really work in North America, and they have really good data. And so they worked on this time scale. And here's part of it. All these names are tied to locations where they had a good fauna, and they were able to loosely tie them to strata, but they put them in sequence. Like the Bridgerian fauna was mainly first discovered in the Bridger Formation. Uinta is northern Utah. Duchenian is Utah. Shadronia is Nebraska. And so they gave all these names and then they put them in this order. And, was it right? People did this with plants too, plant fossils. They tried to do this kind of this zonation. And in 1964, there was a paper out where radiometric dating now was available. And they basically took and dated all the rocks cups that were associated with these faunas, and found out the order was correct, and the mammals really worked for dating. And they did a second paper, I think it's about the same time, and they did it with the plants, and it did not work. Plants don't evolve very quickly, and they tried to do zonation of plants, but little leaves basically, and it was unsuccessful. So anyway, in Montana, there's tons and tons of tertiary rock, and Douglas was Earl Douglas, the starter of it. He went to the University of Montana, got a master's in 1899. throughout his career, he named 73 new species. He published his first major paper in 1901, and soon after that, the Carnegie Museums scooped him up and he started working with the Carnegie Museum. In 1909, he's the guy that found Dinosaur National Monument in Utah. It's a famous picture of him with his row of gigantic sauropod vertebrae exposed. So that made him pretty famous. So the Carnegie came out to Southwest Montana. Wild K was there from 37 to 59. And then Bob Fields, a lot of other museums came out too. Bob Fields came to the University of Minnesota or Montana, and he really kind of took over that project. He had 14 graduate students. I'm one of them. I got there in 1983, got a master's in 1985. I worked in the North Boulder Basin, and Bob was a great mentor. And he and Kunze named the Vernover and 6 Mile Creek formations. So there's a big collection at the University of Montana Paleo Center, basically because of Bob and the students. And then people would collect. After Bob retired, Ralph Nichols, Alan Tabram was one of Bob's students that collected from Montana for a long time, then went to work at the Carnegie Museum, made major collections still there. And Chuck and Debbie had worked a lot with Ralph collecting fossils. You go over the MOR, you see a lot of the stuff they collected. So there's fossils from Southwest Montana all over the place. The U.S. National Museum, the Smithsonian, M&H, New York, MCZ, Harvard, University of Washington. The RAM is the Raymond M Museum. But a lot of these specimens they were not described and published. Some were, but a lot were not. So we're kind of interested in this because we want to study these things. Anyway, the land mammal ages here now are stuck in Hanneman and Wideman sequence. And so with all this data that people had collected all through the time, you can start to put these things age dates based on the fossil mammals. And they refined, this original Wood Committee sequence was always kept the same, but the mammal ages moved around a little bit because of correlations to Europe, where the names like Eocene or Oligocene originated. For instance, the Shadronian here is at 33.9. You see it over there. That used to be in the Oligocene. And radiometric dating around 1990 moved it down into the late Eocene. So I'm going to talk about 3 places we worked quite a bit. Pipestone Springs, which Debbie talked about, the radiometric dating that was done there, and the burrows, and Steve Hasiotis. And then the Gravelly Range, which is high elevation deposits. A really interesting history there. And Sage Creek, which we're working on right now. And we have a paper about 95% done. So Pipestone Springs, this is, like I mentioned, I bought this property in 2005. When I was a graduate student at Montana, Bob Fields told me and a guy named Tony Runkle to go over to Pipestone and make a collection. So this is the very first place I ever collected a vertebrate fossil. And there was a lot of stuff here. It's pretty exciting. There's no houses here or anything like that. And then in 2005, Alan Tabram told me it was for sale. And I just had to have it, so we bought it, and it's a great summer place for our family. And we do work here all the time. So you can see in the background, there's lots of cars. These are Shadronian rocks, latest Eocene, one of the most famous localities in the world for mammals of this age. Over 20 holotypes are known from here. There's lots of small, very small animals where they're pretty common here. And so a lot of species have been named from this site, and there's collections of it all over the United States. And the students, you come out here with 20 students, you got a little army of students, they find stuff. So they pretty much scour the ground and collect everything they can. So you walk out of here after hard days, you got 20 jaws, maybe a couple skulls, and then tons of postcranial material. And this is a typical outcrop. You can see that black thing, that's the skull of a rodent. And so a lot of the stuff you can just pick up, but this had to be excavated. And you never know what's in there, so you make a block around it. And there's a skull on the left. This rodent called Eschiromes, and partial skeleton. So the preservation of this site is incredible. We've, looked at the fauna for taphonomic purposes. And it's interesting, Paleolagus is a rabbit, Eschiromes is a rodent, and artiodactyls are like herbivores, like deer-like animals. So they dominate the fauna. And as far as elements, vertebrae are the most common: toes, phalanges, lower jaws, and things like ribs, kind of fragile, are really rare. But we were really interested, first off, in the coprolites. Coprolites is fossil poop, technical term for that. And there's a lot of them there. And, they're really not mentioned in the literature at all. I think I saw one mention just kind of in passing that there's coprolites there. So we had started amassing a large collection of coprolites, and then we're thinking, okay, who's leaving these coprolites and what are they eating? And you can look at the coprolites, you see the little black things, that's bone. So we got hundreds of them over the years. And there's two basic sizes. Big one, that's a 10 millimeter scale, and small ones. You can tell the size of the animal based on the coprolite. It's basically the size of the anus, right? So big coprolites can be a bigger animal, and small coprolites can be a smaller animal. The smaller ones are much more common, and they have a lot more bone in them. So what are they eating? Well, A is the ankle bone, B is the arm bone, the humerus, the shoulder, and the elbow is C, and D is phalanges, toes. And so these things are being consumed and not completely destroyed by the digestive process. So that's kind of a clue what animal might have eaten them. And then getting more specific animals, A is a lizard osteoderm, so they're eating lizards. B is a rodent tooth, and C and D are rabbit jaws. So Eschiromes is the most common rodent there, and it's the most common thing found in the coprolites. Paleolagus, the rabbit, it's the most common thing collecting, and also in the coprolites. So how to figure out who's a carnivore? I looked at all the carnivores that were at Montana collections, Carnegie collections, American Museum of Natural History collections, and the Alf Museum collections. And so this is a pie diagram. The most common by far is Hesperocyon, which is a canid, a dog, and it's just the right size for the size of the coprolites. Plus, modern canids, you'll see bone that goes all the way through. If you pick up coyote scat in some areas, you can see lots of bones in it. So we hypothesize that this is the carnivore left those, but it's something you can't be 100% sure of. Also we did a paper on lizards. These are Helodermoides, a lizard described by Douglas back in 1903 or 1901. And they really have armored osteoderms like D all over their body. But we were really looking at the new things. For instance, C and D, those are varanid lizards. They've never been described for Montana before. There's about 7 specimens. And then E is a guanid, which is really, really tiny. And interesting, these fossils of pipestone are all over the country, but nobody's described these lizards. They must have them, but they're not described. And when I was at the Smithsonian, I volunteered at the Smithsonian on Wednesdays. I was in the collections, and they had a Pipestone Springs drawer there, and I opened it up, looked in a box, and there was a Varana jaw just sitting there. Probably been sitting there for probably 50 years. It's never been described. So these are the first records of Varana in Montana. And these are snake vertebrae. These are 3 articulated snake vertebrae. They have balls on the end of them. They're really distinctive. And we had like 50 of them. Again, nobody's ever described a snake from Pipestone Springs. And so students and I work together on projects like this. And it's a boid. And all the vertebrae we found are from one species, a boid. And I'm 100% sure there's piles of snake vertebrae at some of these other museums, but again, nobody's described them. So it's important to get back in these collections and get this stuff described. And also, you find new things too. And then there's the gravelly range. This is down near Yellowstone. And Harvard was up, some guy from Princeton was doing a PhD up there in the 50s, and he started finding bones. So he sent them to Glenn Jepson at Princeton University, who identified them as mammals of Oligocene age. And then Harvard heard about it. So they sent a crew up there, and they collected a whole bunch of stuff. Here's one of their specimens. MCZ is Museum of Comparative Zoology. That's the museum at Harvard. Almost none of these specimens were ever published. They only published one rodent because it was a new species. All the other specimens were never figured or published. And you look at their old data. This is Black Butte photograph. And so they have these numbers 2, 3, 4. These are collecting areas they used. So we had to go back there and relocate these areas and see if we could find more things there. And then at the American Museum, the same thing. Malcolm McKenna, a close friend of mine, worked there for a long time. He was one of the most productive mammalian paleontologists in the 20th century. He liked to go to Gravelly Range after he heard that Harvard had been there, but he never wrote up anything either. And when he passed away in 2008, he had 2 drawers of specimens that they just put down in the collections, and none of it's been even cataloged. So I discovered it there, and I looked at the specimens and I thought, there's a lot of great stuff here, besides the stuff at Harvard. I went to Harvard too. So I was able to convince the curators there I picked the 20 best specimens and asked them to please catalog them and send them to me so it could put them in the paper. But again, these have been sitting around for a long time. And Deb Hanneman made these sections, the very thick sections of Black Butte and Lion Mountain on the left, and shorter ones to the right. I mean, that's 140 meters, one's almost 300 meters. So they go from Uinta rocks, mid-Eocene, all the way up to Whitney, which is mid-Oligocene. So there's Shadronian rocks, there's a lot of stuff there. So we incorporated new collections with stuff from Harvard, stuff with the American Museum. And I'll show you some pictures of Black Butte and Lion Mountain. So there's Black Butte, an intrusion, igneous intrusion into the Tertiary. It's been dated at about 31. So this huge pile of tertiaries here, and this igneous intrusion was made into it. Kind of reminds me of Devil's Tower a little bit. It's really distinctive. And in the foreground, you can see somebody looking at for fossils. The outcrops were pretty spotty. There's a lot of cover, but there's some pretty good sites. And so we were able to collect a lot of things, name a couple new species. Up on the upper left, the first couple jaws are a new species called Periumes muffleri. And then on the right, A, B, and C, that's a new species of carnivore called Lycophocyon. We named it after Al Tabram. This Lycophocyon is only found in California. So nobody's found it in Utah or Wyoming. So it's really interesting that the only place it's known before Montana is California. In fact, a lot of the stuff we're finding in the Sage Creek and Gravelly Range is also known from California. And the rodent has been found in Montana, Periumes. This is a new species. So we're finding stuff that's new. Here's a taperoid, like a tapir. This is also MCZ specimen. This is the only known record of this animal outside of California. So again, really rare specimen, only found in California and Gravelly Range. And then the Lion Mountain. This is Shattering rocks, the Whitneyan. And this is a really thick section with a basalt on top, which has kind of protected it from erosion. And so this is like very steep. And it's hard to find things here. And it's hard to get to. It's kind of off the road. But it's a great spot for finding very complete things. There's cliffs there, and somebody left a ladder. Actually, McKenna left a ladder there years ago. And my friend Tony is up there collecting mammals on a cliff face at the almost the top of this outcrop. It's kind of scary just to stand up there, let alone get up on a ladder. But it's worth it because you get incredible specimens. This A and B is the skull and jaws of a marsupial called Herpetotherium fugax. And it's been found elsewhere, but this is the best skull ever found of this animal. It's published in 2020. All the front teeth are there. It's got, in G, you can see them. It's got 5 incisors on each side. Very unusual for just a marsupial. That's not so unusual for marsupial, but nobody'd ever found a complete upper teeth. And never found it in rocks younger as young as the Whitneyan. So another really important specimen that we found. And then we'll get to the Dell area. This area was heavily worked by Al Tabram and Kay at the Carnegie. But all of Douglas's fossils went to the Carnegie Museum, so they have huge collection of his stuff, some of Tabram's stuff, this guy named Kay's stuff. So the largest collection of Southwest Montana tertiary mammals is at the Carnegie by far. And the rocks here are early Oligocene, they go up to the mid-Miocene, but we were working mainly on the oldest rocks, the Sage Creek Formation and the Dell beds. This was Tabram's dissertation in the 1970s, and he never finished it. But his fossils ended up at Montana. And then when he worked at the Carnegie as a preparator, he would come out here all the time to Southwest Montana and make collections. So there's a pretty good record. I was just at the Carnegie about a month ago. So they have compactors, and it's really organized. And so a lot of it's most of it's catalog. So somebody did a lot of work to get this collection in this kind of shape. So you roll these things back and forth to where you want them, then you look at the drawers. Here's the Dell beds, or Uinta rocks, late Eocene, sectivores, rodents, lagomorphs, rabbits, carnivores, perissodactyls, horses, and rhinos. Artiodactyls are things like sheep and goat type animals. So then you're studying them, you just open a drawer and there they all are, jaws and skulls. Pretty awesome. They did a really good job of getting their stuff together. And so you find specimens that you can study there, like this is a taper called gold on KI. This is a holotype. So this is the specimen that actually the animal's based on. And got this picture a couple weeks ago, beautiful specimen. Gene Huff from the Smithsonian collected it and described it in 1955. So this was one thing that was actually described. This is a jaw collected in 1937 from a Mynodont. It's kind of similar to a rhino in some ways, but the teeth are all worn. This specimen's never even been mentioned before. I was surprised to see it there. It was collected by Kay. And so nobody's ever took a picture of it or anything, so it's part of our publication. It's very rare. We work, if you haven't been to the Sage Creek Basin, kind of the middle of the rocks down there are the Sage Creek Formation. The ones on the left are the dell beds. So there's quite a bit of outcrop. It's close up. It's extremely difficult to find anything in the Sage Creek Formation. Really hard. We were there for 5, 6 years now and found one tooth that could be identified in genus. One. The Smithsonian went there for two years in a row and didn't find anything. So if you find something in the Sage Creek Formation, it's really good. Abram found a few things, but man, it's tough. The dell beds are different. There's a lot more rock to look at, and it has more fossils in it. So there's that brown ear tooth we found. It's like golden, but it's a very important specimen, beautiful specimen. There's Deb at the top of the formation. There's a tuff we were dating right there. So we got a couple of tuff dates from the formation, and the age we got on them exactly matches what the age of the mammals tell us about the age of the rock. And then the beds above her is a big paleosol, which defines basically the top of the Sage Creek Formation. And so the main places for the dell beds is Douglas Draw, named after old Douglas. And again, spotty outcrops, but you can find mammals. And some of the dell beds are quite coarse. This is this amazing rhyolite boulder conglomerate. Some of these boulders are 1 foot across, and they're perfectly round. So it's really interesting little fill here of these rhyolite boulders. And this is hoof draw. This is where most of the fossils are found. And they can be big and they can be really small. So you prospect through all these areas and you'll find, here's a specimen of gold on KI, which was found back in 1939 by Kay. Nicely prepared. This was in the super hard rocks. So somebody took a long time to prepare the specimen to get all the bone out of the rock. It's my friend Tony again, crawling on the ground. This is one of our sites where the small stuff is. So you can crawl around, for every mammal fossil you found, like say that one, it'd probably take you half hour to dig it out, maybe an hour. Would it take you 20 times as many hours to prep it, get it out of the rock? So it takes a long time to prep these things that you get out. But if you're looking at float fossils, little teeth and jaws, you can just pick them right up and they just need a little bit of cleaning. So we're trying to find what we call the microfauna here and dry screening this matrix under special permit. And we've been pretty successful in finding the really tiny things. This is a 1 millimeter scale here. This is an insectivore. It's a 4th lower premolar. So there's really tiny, you can't hardly see it on the ground. You have to screen it and look at through the matrix of the microscope to find these things. And then our old friend Periumi's muffler eye, the one that was found up in the gravelly range, is found here too. So this paper is almost ready to go out for review. We've got a lot of, we're naming one new species, all the stuff in the Carnegie, almost all of it hasn't been formally described. So it's going to document that whole area as far as the mammals go. It really doesn't change the age, but you really need to have these fossils described and published so people know they exist. Otherwise, they're just in a drawer somewhere and nobody can see a picture of them or anything like that. Or read a paper and know that they should go there to look at these specimens. So we've been working on sequence 1 down at the bottom. That's where the Sage Creek and hill beds are. Sequence 2, that's where you have pipestone. Gravelly range is both sequence 1 and 2. So we just worked on part, there's still sequence 3 and 4. There's so many specimens that haven't been looked at. It's incredible. So for the future, near future, we're gonna work our way up the section into the Sage Creek up to the Orwellian and Whitneyan, the early Oligocene, and then maybe even up to the Barstowian. But you know, there's just so much to do. You know, at Carnegie, there's so many fossils. You can actually see all Douglas's original stuff. Douglas published all his stuff, but hardly anybody else did. Just parts of it. Other museums a little bit too. So we've got our work cut out for us, and we'll just keep working on it. I just wanted to mention the Montana BLM, Billings and Dillon offices. They've been really helpful getting us permits. A lot of these lands are BLM managed, and the main people that help us is Greg Liggett and Jen Gilbert. And then in the U.S. Forest Service, where the Gravelly Range is, the Madison District, they've really helped. Dale Olson, Eric Torgerson, Bruce Schumacher, William Wilkins. You know, when I was still working, I had a research class for students and they took 2 years of it. And so we would work on projects together. So some of these, like the lizards, a lot of the co-authors on that paper, that was published in 2023. That was a bunch of students. Coprolite paper, lots of students were on that paper. My daughter was actually on that paper. And this Sage Creek paper, same thing. There's a lot of students that studied a lot of these specimens as part of their school. So now they're all gone. I'm retired, so I have to work harder to find things. But still enjoying working as a research paleontologist, specializing in mammals, even though I'm retired, and I've got the house in Pipestone to work out of. So if you ever want to come over to Pipestone, see some fossils, they're out there. They were all shot every time it rains. Anyway, I think that's about 40 minutes. So I'm looking for any questions, complaints, comments.
Yeah, Don, I got a question for you.
Yeah.
I thought that marsupial. You said marsupial, right?
Yeah.
That was an incredible find. So, what does that say about where that came from? Was it something that came across uh, the Bering Land Bridge, or I mean, that's earlier than the Isthmus of Panama deal, right?
Yeah, I mean, you go way back to like the Oligocene and Eocene. The marsupials are really common in North America. They're small, rodent-sized animals, and then they eventually disappear. but they're super common. And you find them at Pipestone. There's 4 species at Pipestone. It's just this one. There's a siltstone that doesn't have a lot of fossils in it, but when you find something, it's pretty complete. And so if you look, you just see a little bit of bone sticking out, and you're looking at it like, oh, I think I see teeth in there. So you dig around it, make sure you got the whole thing, and then pop it out, and then you take it back to the lab, and you don't know what's in there, but man, it was amazing. Same with the lizard skull. We could see a little bit of it. Weren't quite sure what it was, but when it got prepped, it's like, wow, it's the first record of that species in Montana.
Wow.
So
That's great because, I teach historical here at KU, and, the historical book talks about, North America really not having much in the way of marsupials until the
awesome.
Cambridge comes up. So they totally just had like ignore what you guys are finding up there. So it sounds like marsupials were always around in North America.
Yeah, they go back to the Cretaceous, late Cretaceous.
Yeah.
They're 5 or 6 genera just in eastern Montana where I worked. So yeah, they were around for a long time.
Great. Well, I'll have to
And
modify what I teach the kids because that's excellent.
yeah, they're that again was an incredible specimen. We had no idea when we collected it till it was prepped.
Don, so what are the definitive features in the skull and teeth that allow you to differentiate between marsupial and mammal?
Marsupials are mammals.
Sorry, marsupials and placentals.
Yeah, there's basically 3 types of mammals that you see way back, and one are multituberculates, which go extinct by the late Eocene. And then there's the eutherians and metatherians. So it's marsupials are metatherians, eutherians are placentals. And well, the marsupials have really small brains, and their teeth are very different. They have on the back, their lower teeth, they have 2 cusps that are twinned. And that's really a key feature to look at. And some other things. They have a lot of teeth. As you could see, placentals don't have nearly that many teeth. Um, but they're very distinctive. With their lower teeth, they're very different. And, they don't look that much different except for that one feature called twinning. But yeah, there's a lot of marsupials.
Was that twinning evident in the picture of that skull you showed?
No, you could see the upper teeth in that. And the upper teeth are very distinctive too. You have 3 cusps in the upper teeth. Let me go back. You have 3 cusps in the upper teeth, and oops.
Nope.
So you see the one has H. Look at H, and you see the little 2 bumps kind of in the middle of the tooth.
Yep.
And then there's a big shelf that's basically above it. That's called a stylar shelf. And you have a really big stylar shelf on marsupials and you don't on placentals. So that's another distinct feature of it. So when you see an upper tooth of a marsupial too, you can tell it is right away.
Wow. Okay. Great.
So anyway, I've been collecting mammals for a long time, and they're just great index fossils, and they're really important for telling the age of the rock. First thing you look for, got to find some mammals. And lots of times you can't find them where you want to.
Yeah.
You know how that goes.
Thank you.
All right. Well, thanks for listening, everybody.
Oh yeah, we have one question here, Don. Yeah, sorry, wait,
Yeah.
here in the back, we're down. I was curious if you could tell us a little bit about like the ancient environments or depositional environments where you find a lot of these fossils. Are they kind of like wetland type areas, or where do you think a lot of these animals were living and died and preserved?
Just around streams and, floodplain streams, a lot of ashfall tuffs for a lot of ashfall sediments on flat areas. Um, Nothing really tropical looking too much in Montana, but other places in North America, you get a lot of primates. Uh, Not in the Eocene of Montana. Um, so all kinds of, environments you'd see in the valleys today. They have tortoises, a lot of tortoises. Um,
Oh.
yeah, it's that's an unusual. Lots of plants, floodplains, rivers.
I have a question too. There's a lot of debate about, paleo elevations in the Western US. Does the coincidence of some of these species in California and Montana have any implications, you think, on that sort of debate? Can you use that do you have any idea in your mind of what the elevations might have been? Were we really high or really low?
Very good question. You were trying to use plants to determine that, and also, geochem. I'm not really up on that. But if you look at where the rocks are found now, I mean, the gravelly ranges, Lion Mountain, at the top of Lion Mountain, it's 10,000 feet. And the rocks are horizontal up there. It seems pretty high up to have a 10,000-foot basin, but it's hard to tell if it's uplifted, how much. The mammals there are pretty much the same. You see that we see is there at Sage Creek, much lower elevation. So with all the faulting, there is contiguous strata are, hard to document, and then the basins are all broken up, and maybe a lot of those basins were already broken up long ago too. So there's nothing in the mammals I've seen that suggests high elevation that stands out as like, oh, look at there's these species up here up in the gravelly range and we don't see them anywhere else. There's nothing like that. Everything we find is found, other basins that are much lower in elevation now. But doing geochem and figuring out what paleo elevation is a big deal right now, and but I'm not part of that.
Awesome, thank you.
Well,
I have a question. Are you optimistic about finding much in the Miocene sediments? When you start looking for the Barstovian and younger fauna?
well, we always start out very optimistic, but depends on where you are. Like in the North Boulder Basin where I was mapping and collecting fossils. There wasn't a whole lot in the older rock, the Shadronian rocks, and those rocks were full of boulder batholith material. And present day, you have limestones on the east side of the North Boulder Basin and Elkhorn Mountain volcanics on the west side. And you just didn't see it in the sediments. And then when you get up to the Miocene, all of a sudden you're getting rock fragments from both sides. On the east side, you're getting the limestones. On the west side, you're getting the Elkhorn Mountain volcanics. And so there's been some uplift or downdrops. And then you're in the Miocene, basically. And you find, because there's Barstovian fossils, horse leaf horse teeth are a really good index fossil. And so you can tell right away if you're in the Miocene, if you start finding horse teeth versus the Chadronian. And so that whole unconformity in the North Boulder Basin can't really be mapped very well, but you can see the effect of the uplifts in the sediments and the change in the fossils, age of the fossils. And you can find quite a bit of Archeovian fossils in the North Boulder. So I don't know. We'll see. We go to new areas. Maybe it's tough. It's sometimes it's really hard, and other times there's some pretty good stuff. So
you're finding lots of fine grained Miocene sediments?
no,
No?
lots of class, a lot of conglomerates and kind of distal alluvial fan type stuff. That's really local. And the Chadronian stuff was more distal, boulder baths with much finer grain, like tons and tons of Gruss type stuff. It's really striking the difference between the Chadronian sediments and the Barstowian ones, as far as the grain size and the source.
I just want to put in a word for good word for the fine grained Miocene sediments around you. There are some. They're fine and silty rather than conglomeratic. And it'd be very wonderful to find some fossils in there. If you're interested in having a look, I'd be happy to. And we've never met, but Stuart can tell you.
About,
Anyway,
sorry, I wasn't trying to mislead that. There is a lot of fine grained sediments in the Barstowian stuff in North Boulder, but there's a lot of coarser grained stuff too. And that's the finer grained stuff is where you find the horse teeth and on camel skeleton, turtles, little tortoise shells. There's a couple of really good sites there that are fine grained.
I have another quick question. Why is the preservation so good at Pipestone Springs, and why are they so dark?
Well, I can tell you this, the Pipestone Springs preservation is excellent. I think it's been buried without being heavily weathered. And must have been, well, there's carnivore coprolites all over the place. So there's probably a lot of, maybe they're consuming animals and leaving parts of this, stuff on the ground and then pooping it out. Maybe the coprolites are falling apart and don't get buried, and that adds to the fossils. But they're not weathered, and there's whole tortoises there. So, and the bone bearing layer is about 12 feet thick, and there's no bedding in it. It's just massive. So that was kind of a puzzler. Debbie showed really good data. It's mostly airfall. So yeah, and they're black. I don't know why they're black. And there's a site, there's actually 3 pockets of bone on the property, and 2 of them are pipestone level, and there's one that's younger, and the bones are white there, just 50 feet from the ones where they're black. So I don't know if there's manganese thrown through the groundwater or what, but it's striking how different in color they are. Same animals too. So
Cool, awesome.
lucky.
All right, do we have any other questions on here? I don't think so. All right, thank you so much.
All right, thank you for having me. I'll be out there in 2 months.
Oh, excellent.
fine grained sediment, Miocene sediment. Yeah, well.